What's up, my dudes? Mr. Decker here. Unit 3, Lesson 22, Collisions. All right. The computer science standards for this lesson are there and available for you to look at in case you are super interested in what those might be. Giving you some time to read. And good. Essential question: how can programmers build on abstractions to create further abstractions? Good question. This entire lesson is on code.org. Make sure you're signed in there so you can do this assignment, of course, get credit for it, of course, make a good grade, of course. I mean, who doesn't love computer science? Best practice, follow those. And don't forget to answer this weird essential question. I wonder if that will be answered as we go through the lesson. I imagine it will. Okay. Moving forward. All right, so an abstraction. Holy cow, Mr. Decker was so right. So right. Goodness. All right, an abstraction is a simplified representation of something more complex. Oh, okay, that's what that is. It's a simplified representation of something more complex. Abstractions allow you to hide details to help you manage complexity, focus on relevant concepts, and reason about problems at a higher level. So, you remember that velocity block, right? The velocity block is an abstraction because it contains a lot of code inside of it. It doesn't need all those counter patterns, man. It's just doing its job, man. Okay. Pardon the coffee consumption. If ever there's a gap in me talking and there's a silent period, just paint a picture in your head, theater of the mind, Mr. Decker drinking coffee, if that's what you need to do to understand what's happening. Okay, new code, sprite.bounce target. So collisions, we're making sprites interact with each other, right? So it's like there's going to be a lot of touching happening in this lesson. A whole lot of touching going on. All right, sprite.bounce off, sprite.collide, sprite.displace, set collider, and we've played with the collider a little bit before, but now we're going to do some even more complex stuff with it. And then sprite bounciness. I can make my sprites bouncy. So cool. All right. Level 2, Sprite Interactions. So far, you've been able to create a simple sprite interaction by using Sprite is touching block. For example, you've reset a coin to a different location on the screen when a character touches it. Now, it's time to start making sprites have more complex interactions. Just like in the last lesson, we were doing complex movement. Now we're doing complex interactions, which maybe would have been a better title for this one because in an earlier lesson it was, all right, let me look for it, going through my stuff, collision detection, right? Maybe complex collisions would have been a better name for this. Code.org, are you listening? Are you listening? Run the program and observe the interaction between the two sprites. Okay, the giraffe is just slowly moving. Oh, and he pushes the monkey. Okay, interesting. Giraffe pushes monkey. This is like a weird game of rock, paper, scissors. Okay, discuss with a neighbor. Well, you're my neighbor. Howdy, neighbor. Using only the commands you already know how you could you? Oh, wait. Huh? This sentence is broken. Using only the commands you already know how. Oh, imagine there's a comma right there because, grammar is important. Using only the commands you already know, how could you create this kind of interaction? That's the way that sentence should read. Instead, it's like, using only the commands you already know, how could you? No. Using only, my wife is a librarian, okay? It's important to have correct grammar, okay? Using only the commands you already know, how could you create this kind of interaction? There are many ways to do it, and here is a comma. There's a comma. Why didn't they comma here? No comma. There are many ways to do it, but here are some blocks to consider. Sprite is touching, sprite velocity X, sprite velocity Y, sprite X, sprite Y. Be ready to share your ideas with your classmates. Well, you guys are my classmates. I'm your teacher mate, facilitator guy. Okay. So obviously velocity X is being used to make him, or velocity X 1 or something, gets 1 is making him move at that speed, maybe 2. And then maybe there's an if statement. It says like if giraffe is touching monkey, then monkey's velocity y gets, or velocity x, sorry, gets or equals the giraffe's velocity y. You could do something like that. Continue. Bubble 3. Program a sprite interaction. Here's a simple program, but it doesn't work yet. Aw, it doesn't work. What's wrong with it? Do this. Use your plan. I have a plan? I have a plan. Oh, no. That wasn't the plan. Use your plan to program the giraffe to push the monkey off the screen. When did I come up with a plan? On the last one, maybe? Okay, so sprite is touching. So I said an if statement, right? If giraffe is touching monkey, then monkey velocity x equals giraffe velocity x. This is exactly what I said. I thought might make it work on bubble 2. Let's see. Yes. Nailed it. All right. And if we go to the animation tab, here's my monkey face. Here's my giraffe face. Crop them a little bit. Go back to the code. Let's speed this up just a bit. Give them a velocity of 2. Run. Yeah, cool. All right. Continue. Bubble 4. Write your own sprite interaction. Now the elephant should push the hippo off the screen. Notice that the elephant moves at a random y velocity each time the program runs. Right, here's where that's set up. Using the random number block. That's cool. Do this. Run the program to see how it works. All right, so there's no sprite interaction set up for them. Using the patterns from the last level, write code that makes the elephant push the hippo off the screen. So we're just doing the same thing on velocity y, but we need an if statement. You could also do this by like x or y location. But this resolves a lot of the guesswork. And I know you've seen me, and I know you have as well, done a lot of sprite movement using your x and y location to make something happen as a conditional. Sprite is touching. If the elephant is touching the hippo, then the hippo's velocity y is going to equal the elephant's velocity y. Perfect. All right. So let's finish. Continue. Bubble 5, displace. This type of sprite interaction is so common that there's a block for it. Imagine. Sprite.displace. Someone tried to use the sprite.displace block to make the elephant push the hippo, but there is a bug. Oh, uh-oh. Do this. Find the line of code where the sprite.displace block is used and fix the error. Run. Oh. Hippo displace elephant, but we want the elephant to push the hippo. So we want to flip this around. Because in real life, elephants are way bigger than hippos, so the elephant would displace the hippo. Good. So all we had to do is flip those around. If you missed that, when it started, it was hippo displace elephant. So that when it runs, it makes the hippo push the elephant. But we want it to be more realistic, because in that nature sumo match, the elephant's going to win because he weighs way more, right? How much? Okay, let's do this. How much does a gray elephant weigh? In pounds. Adult male Asian elephants weigh between 1,800 and 4,500 kilograms, or between 4,000 and 10,000 pounds. Could you imagine? Okay, now how much does a hippo weigh in pounds? Hippos are also quite big. So hippos weigh as much as elephants? 9,900 pounds a hippo? Let's see what else the internet can do. Hippo. Next to elephant. Yeah, see, but they weigh the same? Oh, yeah. See, this is here's nature at work. A hippo getting displaced by an elephant. All right then. There you go, folks. I'm trying not to steer you wrong. Okay, finish. But I had no idea. Man, an elephant being that size, 10,000 pounds makes sense, but a hippo, what happened? Okay. Level 6. Man, I didn't know hippos weighed practically the same as an elephant. Mind blown. All right, more collision blocks. 3 new types of sprite. Unless I was reading that information wrong, send me an email if I read that information wrong, and you can correct me, because please do, because I want to live in a reality where the bigger animal weighs more, because that seems like it just makes sense in my head. Okay, moving on. Back to programming. More collision blocks. 3 new types of sprite interactions have been added to the toolbox. Yeah, okay, so we've got bounce, bounce off, collide, displace. We've also got the debug is back. Okay, we've seen debug before. 3 new types of sprite interactions have been added to the toolbox: sprite collide, sprite bounce, and sprite bounce off. How do you think they'll affect the sprites? Well, let's find out. Switch the displace block for the sprite.collide, sprite.bounce, and sprite.bounce off blocks. Show me where. Down here, inside the draw loop, imagine. Hint, if you're having trouble doing this with blocks, then switch over to text mode. So, yeah, just remember, you've always got this option. Discuss with a neighbor what is the difference between the 4 different sprite interactions, and what do you think the purpose of each block is? Okay, so parrot displace penguin. And remember, if I switch these, penguin displace parrot, then it's going to run the opposite. So this time, penguin displaces the parrot. Now let's throw that in the trash. Let's see what bounce does. Parrot, penguin, parrot, bounce, penguin. Bing. All right, what happens if I switch this? Anything different? It runs exactly the same. All right, let's try bounce off. So parrot, bounce off, penguin. Oh. Ooh. Okay, let's switch these. Penguin, bounce off, parrot. Ow. Okay, cool. So the collide, we tried that one, right? Collide just makes them run into each other. Parrot, penguin. I don't recall them bouncing anywhere. They just gonna. Oh, okay, yeah, they push. Parrot pushes penguin, and then okay, so this is like a push. The bounce just means they hit each other and they go opposite directions at the same speed, and then bounce off depending on which is the target is going to determine which one goes flying. Okay, cool. That's neat. Okay, we got 4 activities to do here. Collision types. Make the basketball interact with the wooden floor. All right. Collision types. There are 4 types of collisions that we use in Game Lab: displace, collide, bounce, and bounce off. These blocks will cause a certain type of interaction between the sprite and its target. Choose the best block to model the basketball's interaction with the floor. Show me where. Down here in the draw loop. All right, so let's run it. It just falls right through the floor, and the wood. Okay, so that's good. That's good. Hint: you can try different blocks out or read more about them in the Help and Tips tab. So let's see. We've got rotation speed, velocities being added to here, but we need to add the collision down here. So what? Okay. Bounce off. So we'll do basketball, bounce off wood. Hey, that works really well. If I do collide, what happens then? Okay. If I do bounce, what happens? Oh, broke the floor. Bam. Okay, so definitely bounce off. Make it a natural, obeying physics in the real world. Bounce. Okay, cool. Collision types. Make the arrow stop at the apple. Classic. Collision types. There are 4 types of collisions that we use in Game Lab: displace, collide, bounce, and bounce off. These blocks will cause a certain type of interaction between the sprite and its target. Do this. Choose the best block to make the arrow stop when it reaches the apple. Run it. Shoom. Okay. Make it stop. I don't want to displace, just collide maybe. arrow, collide, apple. How to spell apple right. There we go. There we go. Done. Finish. Next. Continue. Collision types. Make one cart push the next. I want it to do this. So there are 4 types of collisions. We did that already. We've read that a couple times now. Choose the best block to make the gray minecart stop and push the second cart. Bounce. Which one's which? Gray. Oh, whoop, up, down here. Gray cart. Oh, camel case. Don't forget your camels. All right. Blue cart. Perfect. That's what we wanted, right? Yep. Finish. Continue. Next one, collision types. Help her push the suitcase. Okay. Choose the block to make the child push the suitcase, like over here. Okay. Pushing the suitcase. Pushing the suitcase. Displace. So, kid, displace suitcase. Oh, yeah. Going to the airport. Or what? Or that's a train. Never mind. Sprite Interactions, Bubble 8. You've now seen 4 different types of Sprite Interactions. You'll need them all for this challenge. Do this. For each pair of animals, choose a Sprite Interaction that matches the target image on the right. Oh, okay. So what's going on over here? Ooh. Okay, so there's probably a bounce off, looks like there's some displacement going on. Let's see. Bounce off. It's that bottom one. Pig, bounce off. Is there a snake? Snake. Oh, I need to. Okay, let's just do these in order. Giraffe, bounce, parrot. Run. Okay. And then hippo, displace elephant. This next one, I think. Yep. Yep. Okay, what's the next one? Monkey, displace rabbit. Run. Yep. Okay, and then bounce off for this last one. So snake, bounce off, pig. Run it. Got it. Finish. Continue. Bubble 9, we've got 3 challenges here. So debug colliders. Set a sprite's debug property to understand how it bounces. All right. Sometimes sprites will behave in ways that are unexpected. There is a special sprite.debug property you can use to better understand why the sprites interact the way that they do. Do this. These 2 coins are round, so you would expect them to bounce in a certain way. Something weird is happening, though. Run. Yeah. So let's see here. Sprite.debug. gold coin, camel case, true. And then down here, sprite.debug. Oh, it already has these. Okay, well, there we go. True and true. That will show me their hitboxes. So I want to set their colliders, but use the sprite debug block to make the debug true for both the sprites and run the code again. Change the gold coin starting X position to 51. Gold coin to 51. Run the code again. Okay, so what was it before? 49? So when you run it like this, the gold coin goes down, gray coin goes up, or silver coin, sorry. And then if I change that, gold coin goes up, silver coin goes down. Okay, so I'm not actually debugging it, just seeing why it's working like that. Okay, well, if I had a sprite.set collider, I could make the hitboxes round and they would just bounce off each other going this way and this way. But it's not letting me do that. Okay. Oh, collider shape. Here we go. Now, sprites interact based on the size and shape of their collider, not the images that are assigned to them. You can only see the collider when debug mode is turned on, making it true or false. You can change the shape of the collider using the sprite.set collider block, which lets you pick between a rectangle or a circle. By default, all colliders are a rectangle. Do this. Find the sprite.set collider block for the gold coin. Right here. Change it to a circle. Boop. And then add a new sprite set collider block for the silver coin and choose circle for that one. So sprite.set collider from the toolbox. Silver coin, camel case, make it a circle. Done. See now, like I was trying to explain before, they just bounce off each other now. Now, if you make them rectangles, they get wonky. You don't want them to be rectangles. See? Want them to be circles. All right. Bounciness, last one. Control how much the sprites bounce when they interact. So far, bounce off has made sprites bounce away from other objects as fast as they bounced into them. In the real world, almost everything slows down just a little bit when it bounces off of something else. You can use the Bounciness block to tell your sprite how much to slow down or speed up when it bounces off of something else. Let's see. So I want this animation to happen where this bounces just a little bit, the basketball bounces more, but the soccer ball bounces the most. Okay. Read the code below and press run to see the behavior of the basketball and the pool ball. Use Bounciness block to set the bounciness of your soccer ball. Run the code again to see how the sprites bounce off the floor. So okay, so reset run. So they bounce less and less each time, but the soccer ball is bouncing more. So bounce off, bounce off, bounce off. Oh, okay. Bounciness is set up here. Bounciness for the basketball is 0.8. bounciness for the pool ball on line 10 is 0.4. So let's make the bounciness of the soccer ball like 0.6. Cool. I like it. So setting the bounciness makes that happen. Very cool. Finish. Continue. All right, that's all of the challenges. You can go into free play if you want to, but it's not required. That's it for this lesson. Hope you enjoyed it as much as I did.